Listen up. Are you ready for the ultimate coding challenge? Here's a chance to win a Tesla Cybertruck or $100,000. All you have to do is build an app with a front end and back end and deploy it on WSO2's Choreo, an internal developer platform. The more you do with Choreo, the more chances you have to win. For all the details, go to choreo.dev/Cybertruck. Sign up, get started, and possibly win a Tesla Cybertruck or $100,000. Plus, 10 more winners get MacBook Pros. But hurry, because the challenge ends on April 30th. Good luck.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We are coming to you live from the massive Cloudcast studios here in Raleigh, North Carolina. Hope everybody is doing well. We are now officially into spring. By the time you listen to this, we will be well past March 21st or March 20th, whenever you celebrate spring. The year is moving along. Hopefully everybody who is listening to this on Sunday, your March Madness brackets have not been completely busted by the time you get to this on Sunday. A couple of rounds of games will have happened for those of you living in the States or those of you that are college basketball fans. This time of year is sort of the mecca of March Madness, the mecca of enjoyment of watching small teams beat large teams and all the Cinderella stories and stuff like that. So hope everybody's doing well. Another Sunday Perspective show, and I wanted to talk about. I had a chance to be a guest maybe a month or so ago on a podcast called Altitude, which was run by the good folks over at Aviatrix, and we really weren't talking so much about networking, but really talking about, where cloud computing was going, kind of the intersection of cloud computing and AI, cloud computing and, kind of cloud and multi-cloud and hybrid cloud and all those sort of things. And one of the things that I mentioned, I was a guest, so I mentioned about, kind of where AI was intersecting with cloud. And the folks who were conducting the interview kind of said, hey, does it feel like AI is going to be the thing that ultimately drags everything into the cloud because, there's so many GPUs in Azure or AWS or GCP or in some of these managed cloud hosting services. And where the discussion ended up going was sort of, I'm not sure that's exactly going to happen. There's a lot of opportunity because so much of companies' data lives on premises. People are going to want to build models that are close to their data. They've got security concerns. And so anyways, we got into this sort of long discussion about, how AI is really kind of an interesting kind of use case for, the concept of hybrid cloud or multi-cloud and so forth. But anyways, as part of that discussion, we were talking about skill sets and companies evolving to use AI and what they were going to need to be successful and what could we have learned from the last 10 years or so of cloud computing. And one of the things that I mentioned, and didn't really dive into thinking about it so much. It just kind of popped in my head. But there was an old phrase when we first started doing cloud computing and the old kind of clouderati, the early adopters of cloud. And one of the things they would often say is that, if you don't do IT well today, meaning you don't automate things well, you don't secure things well, you don't have, good best practices and good hygiene and so forth. If you don't do IT well, you're probably not going to do cloud well because cloud doesn't just magically make all of your problems in IT and your warts and your issues go away. They're going to accentuate them. And in fact, because the expectation of cloud is that things move faster, scale bigger than they did before, have more flexibility and agility built in. If you had struggles in IT, you were going to struggle even more in cloud. And so I sort of took that a step further and said, look, if over the last decade or so you haven't figured out how to do cloud-like things well, you're going to struggle with AI because ultimately AI is going to take a lot of the things that you do today in terms of how you organize your teams, how you deal with large amounts of data, how you are iterating and retraining and fine-tuning and deploying frequently and getting feedback loops and so forth. So if you're not doing cloud fundamentals well, you're going to struggle with AI. And so I thought it might be useful to do a show today as a Sunday perspective on sort of 5 important cloud capabilities that you're going to need in order to succeed in the IT world. So we'll dig into that right after the break. And we're back. And as I mentioned at the top of the show, we're going to dig into kind of a listicle type of show today. But 5 important cloud capabilities that I think you really need to be looking at. Do you do these well before you start taking on a bunch of AI projects? And this is one of these scenarios in which I think what we're seeing with AI, at least today, is so many companies are excited about it. You've got a lot of executives who are starting to put funding into projects, things that maybe have potential, things that are experimental. They're not exactly sure what's going to happen. And early on, you're going to see a lot of kind of one-off projects, a lot of, kind of shadow AI, if you will. And it won't necessarily look exactly like it will a couple of years from now once you've figured out, can I make this technology work? Can we accomplish some things that change how we work with our customers or make us more productive or reduce costs in some ways, some of those big 3 or 4 things. But over time, we're going to see more and more companies that say, okay, I want to take advantage of AI, but I want to make sure that I'm doing it in an efficient way, because making a mistake in cloud, you could have gotten a decent sized bill. So maybe you spun up an instance in the wrong region, or you forgot about something, or, you didn't realize that your architecture didn't scale a certain way. And so, you got one of those, Corey Quinn unexpected bills that you kind of go fix. With AI, I mean, you could run up a mistake. Mistake might cost you $100,000, $200,000, $1 million, multiple millions of dollars, just because the cost of GPUs and training cycles and, loading large amounts of data into the system can be very, very expensive. And if you don't know what you're doing, those experiments and those mistakes could be an order of magnitude more expensive, right? So we're going to see over time, as companies begin to figure this stuff out, they're going to want to maybe not make some of the mistakes that we've seen. I don't say mistakes, but just sort of unexpected situations happen that maybe they saw with cloud computing when they really didn't, like I said, didn't have their sort of house in order, didn't necessarily know how to do IT well. So let me kind of go through these. They're not necessarily in any particular order in terms of 1 through 5, but I think they're things that, once you begin to get past the, hey, we played around with some system, with some model, with some capability, and it started to work, that you're going to want to make sure you have in place in order to be able to bring multiple teams in, to learn from multiple projects, to do things at scale and to do things cost effectively. So first thing is, I'm kind of calling automate everything, right? You've got to ultimately think about automation, not just as a nice to have, not just as sort of an add-on thing once you've figured out how to do something, but you almost have to think about automation as mission critical, because the ability to scale out infrastructure is needed for GPUs and for networking and storage and so forth. It's going to be really important. It's not that the automation is all that much different than it was in the past, but I think we want to think about automation as being not just a day 1 thing where we're thinking about deploying, or a day 1.5 or day 2 thing where maybe deploying a patch or something. But how do we think about automation as being much more mission critical? Can it respond to real-time events and then kick off things? So it can be more event driven and stuff like that. The second thing is you really want to think about building the right abstractions and flexibilities, right? So let me give you a couple of examples. One of the things that your development teams, your data science teams are going to ask for, because they did the exact same thing in the cloud era, is I want my own machines. I want my own server to be able to work on this. And you're going to ask for their own servers with their own GPUs. And while that makes life super simple for them, because, hey, these are my toys, this is my playground, I don't have to worry about anybody keeping up with how long have I been running this, am I effective with it? That's incredibly expensive. I mean, you imagine you have several hundred, for example, data scientists working on things. You're not necessarily going to be able to give them their own sandbox, their own playground, their own servers with GPUs. Those things are, tens and hundreds of thousands of dollars. So you want to start figuring out, how do I do the right kind of abstraction? So things like, can we do GPU sharing? Can we do, sort of splicing and so forth of GPUs? Can I do this on a time basis? What can we do in terms of development tools? How do I provide developers with, whether you're using tools like Backstage or other things, to give them self-service development environments, kind of build the platform engineering types of abstractions such that your data scientists can do the things that they want to do, that they need to do. You can efficiently use the underlying resources and infrastructure and so forth. And you can, put the right kind of guardrails where they make sense, right? Right now, you may not need a lot of guardrails. You're just trying to go fast. but over time you are going to want, certain things in place, certain abstractions in place that help make sure that, developers don't, create a multi-million-dollar problem for you or expose data they weren't supposed to expose or overwhelm a cluster because, you were asked to do a training run in 8 hours and you don't have enough GPUs to do something like that. So, build those right abstractions and flexibilities in and think about them early in the process, because as you scale, you don't want the project, when it starts to get momentum in your company, to just fall down. Now, third thing is to think about, as you've built some of those abstractions, you've built some of that flexibility, are you leveraging platforms, right? The platforms that you're building upon, the platforms you're testing upon, deploying upon, are you building them to bring together the data science team, the MLOps team, and the AppDev team? Because ultimately, the data scientist or even data scientist plus MLOps kind of can't operate in a vacuum, right? So this is sort of the evolution of DevOps, right? Can I bring the developers together and the operations teams together in order to be able to say, look, the ultimate goal is let's allow the developers to build business logic to bring and add value to the business and not have to worry so much about underlying, security and deployments and networking and storage configurations. The same sort of thing is going to happen where I've got to bring together the teams that deal with data and models and be able to do training and do iteration and redeployments and all that sort of stuff, and then bring them together with the application teams who then, are probably going to be tied to the hips with the ops team. So this is really going to be sort of like data science, dev ops, if you will. And so you want to be thinking about, do the platforms or the abstractions that I'm building, do they create walls between these groups, or do they create sort of free-flowing collaborative workspaces such that, once those models are built and they want to expose an API, that it's easy to expose that API to the application team, right? They don't have to fight over how is security deployed, within that environment. Do we have enough resources to make this work? Am I going to be able to get it worked on my laptop scenario to work in dev and test or production? How much do I have to change? So you want to be thinking those teams have to come together, right? They're going to have to work together. They're going to have to work collaboratively. How do I build platforms or take advantage of platforms that allow them to work more cohesively together? Fourth thing on the list, and this is going to sound obvious, but given the fact that really over the last couple of years since COVID has been sort of winding down, and we've looked at the numbers from a number of the cloud providers, and they've been, slowed down more than they had. So much of what they were talking about was that their customers were having to go back and right-size things. They basically figured out they had no idea how to do spending in the cloud, i.e. they had no cost controls, they had no FinOps, they had no idea how to size out projects and so forth, and they were just throwing things in the cloud. Granted, part of that was driven by COVID, but part of it was just driven by, hey, it's really easy to spin stuff up, IT's not getting in my way. And then they started realizing, oh, wait a second, I'm paying huge costs for doing this, right? The cloud isn't necessarily cheap, especially in production when I've got to run it, on higher performance machines, and I want to be able to have DR and backup and all the sorts of things I need for production. So as I mentioned earlier, as we get into AI, the cost of AI, the cost of entry is not cheap. The cost of mistakes is not cheap, but just the cost of doing day-to-day operations, whether it's deployments, whether it's testing, whether it's inferencing, whether it's fine-tuning or RAG or whatever models you're using and building, you want to start thinking earlier on, do we have some mechanism in place and some visibility in place so that we understand the cost of it? Because at the end of the day, AI is super powerful, and it's probably the first generation of applications that are going to come along that you're going to be able to, I don't want to say automatically, but more or less be able to go, this is the goal of what this is going to be, and I can associate costs with those goals. So if my goal is to be like, I want to make my developers 50% more productive, what would 50% more productive look like in terms of like business output? And then I can kind of measure that against, well, what's it going to cost for me to get them to say 50% more productive, right? Or whatever the measure or the metric you want is. I'm trying to reduce cycle times of doing analysis using computer vision to do preventative maintenance on things, or whatever it is. We want to do recommendations, and we know if we do recommendations, we should get 20% uplift on the sales in our retail channels, and therefore, our sales should look like this. Okay, right. Whereas if I'm just building like a new Java application, or I'm building some new, simpler way to keep track of customer projects or something, like being able to figure out the ROI of that is sort of complicated, because you're like, well, I guess it'd be better, but do we really need it? That kind of math. AI, I think, is going to drive much more, I don't want to say simpler, but simpler ways of saying, this is the goal, this is the outcome from a business perspective, this is what it's going to cost. And so you want to have sort of financial visibility at a minimum, and then, controls to help you understand, like, okay, when we get way outside a baseline, or when the bill shows up and we're really not sure what's going on with it, what are we going to do at that point? Right. Now, so we've hit on the first four. The first four are very much driven around technology. So automation, make automation mission critical, because again, the faster you're trying to drive results with AI, the more you're going to need sort of everything in the system automated. Second, build the right abstractions, make sure you can do the right kind of sharing, you can give self-service access, all the sort of things that we've been driving for a number of years around sort of DevOps meets platform engineering type of things. Third, leverage platforms to help bring your teams together, make it easier for them to work together. We kind of got some of those things right in the DevOps world. You really want to get those things right in the sort of data scientist meets MLOps meets AppDev world, right? Fourth thing, obviously, make sure your costs aren't getting out of control. You've got visibility. Now, the last thing that I'll say, and we talked about this a lot, and we saw some early of these things happen, and then we saw, the typical, kind of fragmentation happen, is when you see success, because so much of AI has the ability to be really, really interesting. And at the same time, it has the ability that if you get it wrong, to be, problematic, right? And problematic could be very expensive. Problematic could be, Gen AI hallucinations that, potentially cost your company money in lawsuits. We've started to see some of that start to happen. We've seen misuse of how do I go about using public models, for example, and you dump your company data out into a public model, and then you're wondering why your competitors were able to kind of get wind of it. So we want to make sure that the successes that happen are well publicized, at least internally, right? So you want to think about, how do I take advantage of a situation in which a team figured something out, they did something well, they were able to benefit the business, and given the fact that the data scientists and MLOps people and just kind of all of the skill sets in this domain are pretty rare these days, right? There's just not tons of them floating around. There's just not a lot of people that have, more than 6 months experience, or a year experience, or 2 years experience in some of these new technologies. So you want to be thinking as a company, how do I, when we do find success, how do we socialize it? How do we document the best practices of it? How do we encourage those teams to take those 1 or 2 extra steps, to make sure that what they did isn't a snowflake, that there can be some amount of learning or reuse, or, 1 + 1 = 3 kind of scalability that can be helpful throughout the rest of the company. And I know in some companies, that won't necessarily happen because they're kind of siloed or Chinese firewalled off. In some companies, you've got people who are like, I'm not giving up my secrets because that's going to help me get promoted versus somebody else getting promoted. But I guess my guidance is, if you are a leadership organization and you're funding these projects, you do want to think about, well, what will be the motivation, the incentive structure that I need in order to sort of be able to do that? Because again, at the end of the day, everybody's got an idea of what would be a cool thing to do with AI. There will be more napkins floating around that have ideas and whiteboards written and so forth. But at the end of the day, data scientists aren't growing on trees yet. They're not a dime a dozen. They're not a commodity. They're still a very expensive resource. They're hard to find. And people that know how to do this stuff well and can do it in, weeks instead of months instead of years, are going to be difficult to find, in many cases, fairly expensive. So you want to figure out how do we socialize successes? How do we incentivize people to take that next step and do that? And that's sort of my last item here on my list of 5. So automation, abstractions, platforms for collaboration, understanding cost, and then socializing success, or even socializing failures, right? So that you don't make the same mistakes twice. So a little bit of technology in there, a little bit of collaboration, a little bit of, kind of people plus process plus the technology, similar to what we had when we first got started with cloud. Some people heeded that advice and they did it well. Others, kind of wanted to take their old models and just sort of jam them into the new world. We found in many cases those didn't work. Hopefully you're learning from the last 5 years, 10 years of what happens when we have a technology transition, that if you don't get the fundamentals right and you don't, kind of invest in those things, the odds are, you may be coming back a year, 2 years from now and people go like, hey, how's it going? And you're like, well, I got a humongous bill. I got a humongous amount of cost that we've spent and not as many outputs as we really wanted to, or successes that we want. So anyways, hopefully, you kind of heed the advice that if you want to do AI well, you got to do some cloud fundamentals. You got to have some cloud fundamentals. And those cloud fundamentals don't necessarily have to be public cloud fundamentals, but they want to be the way of doing things in a cloud way, right? Self-service, API-driven, scalable, taking advantage of self-service, having teams collaborate together, thinking about workflows, thinking about business value, all those things kind of coming together. So anyways, with that, I'll wrap it up. Hope everybody has enjoyed this Sunday perspective. Again, hopefully your March Madness bracket is still intact and you're doing well, or at least you're enjoying the games. Hopefully you're enjoying the weather wherever you are. Hopefully it's getting a little bit warmer here. It's supposed to be sunny and warm on the 21st and so forth and going forward. So anyways, happy spring to everybody. Happy Sunday perspectives. Thank you all for listening. Thanks for telling a friend. Thanks for rating the show, giving us feedback. We'd love 5 stars if you get a chance to. If you enjoy the show, we'd love that. It helps us grow the show. It helps more people find it through the way that they find podcasts. So with that, I'll wrap it up and we'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.